Let's take a closer look at how we can measure the enthalpy change for a reaction. We do this something called calorimetry. The simplest calorimeter that you're familiar with is the coffee cup calorimeter. The coffee cup calorimeter has a nearly adiabatic boundary, which is the styrofoam coffee cup, between the system and surroundings and the rest of the universe. The solution inside the coffee cup calorimeter is both the system and the surroundings. In this case, our system is the reacting molecules in the solution, and the surroundings are the solvent molecules in the solution. Notice that there is no boundary between the system and the surroundings, rather the system is dispersed within the surroundings. We typically perform these experiments at constant pressure, so we have a loosely fitting lid, which allows atmospheric pressure to equalize between the outside and the inside of the coffee cup calorimeter. Recall that when we do this experiment at constant pressure, that the heat evolved is equal to delta H for the system. When the reacting molecules or our system undergoes reaction, they will either give off energy or require energy for that reaction to occur. The energy that the reacting molecules give off or take in goes to the surroundings, the solvent molecules. And so the energy that is picked up by the solvent molecules as heat is equal and opposite to the amount of energy as heat given off or taken in by the reaction. Recall that delta H is equal to the constant pressure heat capacity times the change in temperature. If we know the constant pressure heat capacity of the solution, or the surroundings, then we can calculate the amount of heat taken in or given off by these surroundings or solvent. So we can write that delta H of reaction is equal to minus the constant pressure heat capacity of the solvent times delta T. Notice that we are measuring the change in temperature. We know the constant pressure heat capacity of the solvent, and that allows us to calculate from experimental data the delta H of reaction. Let's think about the units of this equation. Typically, we have a heat capacity that is in terms of joules per mole Kelvin. And so that would mean that if we multiply that by a temperature, or a change in temperature, which has units of Kelvin, that the heat capacity times the change in temperature will be joules per mole Kelvin times Kelvin. And so the Kelvins divide out, and so I end up with a delta H that has units of joules per mole. So the amount of energy per mole. If instead of the heat capacity, I use the specific heat, so remember that specific heat has the units of joules per gram Kelvin, then when I multiply the specific heat times the change in temperature, I will get units of joules per gram. Now this is going to be joules per gram of the solvent. And so it's important that I keep track of what I mean by per gram and per mole. Since I'm measuring the temperature change in the solvent, then and I'm using the heat capacity of the solvent, this is the grams of solvent or the moles of solvent. And so if I want the delta H in terms of moles of reacting molecules, I'm going to have to convert this from grams of solvent to moles of reacting molecules. So if we let the units guide our thinking, we can see that if we would multiply this by the mass of solvent in my cup, so if we multiply by the mass of solvent molecules times the specific heat of the solvent molecules times the change in temperature, that I will get an answer that has units of joules, just simply energy. That is the amount of energy that's transferred from the reacting molecules to the solvent molecules, or from the solvent molecules to the reacting molecules. And so it's that value that is actually equal to the amount of energy transferred. Then if I want my change in reaction energy to be per mole of reacting molecules, I simply have to figure out how many moles of molecules have reacted and divide this energy by the number of moles of reacting molecules. So I would need to divide by the number of moles of reaction that has been done, and then I will have my delta H in terms of joules per mole of reaction. So in summary, the delta H for the reaction is equal to minus the mass of solvent or solution in my cup times the specific heat of that solution times the change in temperature of that solution divided by the number of moles of reaction that have occurred. And that is the way we will calculate the change in energy for the reaction.